For most of the 20th century, we believed we knew the answer to one of humanity's oldest questions. Where did we come from? The story was simple, elegant even. Modern humans evolved in Africa, from a small population living in a specific region, and from there they spread out across the world, replacing all other archaic human groups in their path. It was a powerful narrative, clear, linear, and seemingly supported by fossil and genetic evidence. But now, that story is unraveling. In its place emerges a far more complicated and fascinating tale, one that stretches across continents, through deep time, and into the shadows of ancient DNA. A tale of divergence, survival, and mystery. David Reich, a leading geneticist at Harvard University, recently shook the foundations of paleoanthropology with a single sentence: "We have no idea where our ancestors truly came from." His research suggests that the long-held idea of a single African cradle of humanity may be too simplistic. Instead, the evidence is pointing toward a complex web of interactions between ancient populations across both Africa and Eurasia. From roughly 2 million to 500,000 years ago, early humans lived across vast territories, not just in Africa, but throughout Eurasia as well. In both regions, hominins were evolving larger brains, making tools, and adapting to changing environments. There is no clear genetic or fossil evidence pointing to one region over the other as the definitive birthplace of modern humans. Around 650,000 years ago, Earth entered one of its coldest and most hostile periods, marine isotope stage 16. Temperatures dropped over 5 degrees Celsius. Massive ice sheets blanketed northern Europe and Asia. Forests turned to deserts, grasslands to frozen wastelands. Entire ecosystems collapsed. It was not merely a climate event, it was an evolutionary bottleneck. Archaic human populations across both continents were pushed to the brink. And somewhere in this brutal chapter of prehistory, the great human split occurred. A single ancestral population fractured into at least 4 genetically distinct lineages. From this split would arise the Neanderthals, the Denisovans, Homo sapiens, and a fourth unknown group, traced only through faint genetic echoes still present in some modern African populations.
This divergence didn't happen in a single moment. It unfolded slowly, shaped by geography, isolation, and survival. Some scientists believe the split was driven by the changing rhythms of Earth's ice ages. Prior to this period, glacial cycles came and went roughly 41,000 years. But around 900,000 to 600,000 years ago, those rhythms changed. Glaciers grew deeper, stayed longer. The world became more unstable, and the hominins who survived were those who could adapt, not just physically, but socially and cognitively. During the coldest phase, most of northern Eurasia became uninhabitable. In Africa, deserts expanded, and once lush regions dried out. Yet life persisted in small, scattered pockets of survivable habitat known as refugia. Sub-Saharan Africa, the Levant, Southeast Asia, parts of India, and island chains like Sundaland, these became sanctuaries for human evolution. Isolated from one another, these groups evolved separately. Genetic evidence shows that it was from these refuges that the 4 major lineages emerged. And while the Neanderthals and Denisovans have left behind bones and DNA, that 4th lineage, what researchers call a ghost population, has never been identified in the fossil record. It's known only through its genetic legacy in modern West African populations, where up to 19% of DNA in some groups appears to come from this mysterious ancestor. A new wave of research is now challenging old timelines. geneticists have developed tools that better account for hidden population structure in ancient DNA. These tools suggest that Neanderthals and Denisovans split from each other roughly 744,000 years ago, much earlier than previously thought. That split occurred just 300 generations after they separated from the common ancestor they shared with Homo sapiens. And right before that split, the ancestral population of Neanderthals and Denisovans nearly went extinct, shrinking to as few as 500 individuals. But the Neanderthal line rebounded, growing into a vast and regionally diverse population across Western Eurasia. Far from the outdated image of small, scattered bands, Neanderthals may have numbered in the tens of thousands, organized into fragmented subgroups with limited gene flow between them. Their cousins, the Denisovans, were more elusive. They likely diverged from the ancestral stock around 650,000 years ago and migrated eastward, settling in East and Southeast Asia. Their fossil record is sparse, just a few bones and teeth, but their genetic signature lives on in modern populations across Asia and Oceania. Some of their adaptations, such as high-altitude traits in Tibetans and immune system markers in Melanesians, still help humans survive today.
Fossils like the skull found in China, known as Dragon Man, may belong to this elusive group. And according to researchers like Chris Stringer, this skull could lie close to the last common ancestor shared between Denisovans and modern humans. Meanwhile, biogeographic data reveals something striking. Africa was not just the source of human migrations, it was part of a constant back-and-forth flow of populations. Asia, for instance, absorbed nearly 42% of all dispersals, while Africa sent out about 40%. The movement wasn't one way. It was a multidirectional shuttle of migration, interaction, and evolution. Y chromosome analysis shows that modern humans and Neanderthals likely split before 590,000 years ago. Other evidence, such as tooth shape comparisons, pushes that date even earlier, possibly as far back as 800,000 years ago. And that raises a difficult question. If Homo heidelbergensis was long considered the ancestor of both Neanderthals and modern humans, why does the genetic evidence now suggest otherwise? Some fossils assigned to heidelbergensis look more like modern humans than Neanderthals. Others don't fit either lineage. The truth may be that the name heidelbergensis masks multiple species and evolutionary paths. It may be a catch-all for unrelated groups that simply lived during the same period. And here lies the heart of the mystery. We still do not know who or what the last common ancestor of Neanderthals, Denisovans, and modern humans truly was. It may have lived in Africa, it may have lived in Europe, or it may have emerged somewhere else entirely, perhaps in southern Asia where conditions were more stable and the fossil record is still poorly explored. Even today, no universally accepted fossil represents this last common ancestor. It may be that we've already found it but failed to recognize it for what it was. Or worse, it may have left no trace at all. Some researchers believe this missing ancestor lived in a region where fossil preservation is poor, or that its remains are simply buried in layers we haven't yet uncovered. Others suspect it's been hiding in plain sight, classified incorrectly, misunderstood, or assigned to a known species like Homo heidelbergensis without realizing its true importance. Whatever the case, one thing is becoming clear. The path to modern humans was not a straight line. It was a branching, twisting, broken trail shaped by climate, chance, and the fragile survival of small, scattered populations.
In West Africa, scientists have discovered that some populations carry DNA from that mysterious ghost lineage, an archaic group that diverged from the main hominin line around 650,000 years ago and possibly lived until as recently as 124,000 years ago.
They may never have left behind bones that we can find, but their genetic fingerprints still exist. This discovery changes how we understand Africa itself, not as a single unified homeland for modern humans, but as a complex continent filled with multiple human groups evolving side by side. These groups may have exchanged genes, tools, and culture for hundreds of thousands of years. It was only much later that they coalesced into what we now recognize as Homo sapiens. Meanwhile, Europe was undergoing its own evolutionary story. Around 430,000 years ago, in the caves of Atapuerca, Spain, a population of archaic humans left behind bones now known as the cima de los huesos remains. These individuals display traits that are clearly Neanderthal, though not yet fully formed. Their nuclear DNA places them firmly in the Neanderthal lineage, but surprisingly, their mitochondrial DNA, passed down from mothers, looks more like that of Denisovans. This puzzling mix suggests interbreeding with yet another archaic group, possibly Homo erectus or some unknown population that once roamed Eurasia. Isolation caused by glaciation may have confined these early Neanderthals to southwestern Europe, pushing them to evolve in unique and robust ways. The Neanderthal face, with its pronounced brow ridges and large nose, might not be primitive at all. Some researchers argue it's actually more specialized than ours. Paradoxically, it may be that our so-called modern face is the ancient one, the face of the last common ancestor, retained in Homo sapiens, while our cousins diverged into more specialized forms. All of this calls into question the long-dominant out-of-Africa theory, which claims that Homo sapiens evolved in a small region of Africa and then replaced all other archaic humans without interbreeding. Today, scientists are considering more nuanced models. One of them, the shuttle dispersal model, describes a multidirectional flow of humans and genes between Africa, Europe, and Asia. This model better fits the evidence of overlapping traits, shared genes, and ancient migration routes. During glacial periods, regions like Northeast Africa and the Middle East may have functioned as a single ecological zone thanks to lower sea levels and shared biomes. The Red Sea, often imagined as a Great Barrier, may not have been much of one at all. This vast region could have served as the central hub for populations that gave rise to Homo sapiens. From this homeland, groups spread out into eastern and southern Africa, becoming isolated in places like the Ethiopian highlands or the forests near Lake Victoria. These were the refuges, natural laboratories of evolution where small populations drifted genetically and culturally until eventually one group emerged with the traits we now call human.
But even the name Homo heidelbergensis, often given to these ancient ancestors, may be misleading. Fossils in Africa, once labeled as heidelbergensis, are likely a mix. Some may be ancestral to us, others not. The reality is more complex than we thought. Genetic studies show that African populations around 600,000 years ago were already diverging from their European and Asian cousins. This suggests that what we're calling heidelbergensis might not be a single species, but a label we've used to cover up our lack of understanding. This confusion is not just academic. It reflects a deeper truth about how science grapples with uncertainty. We crave clear categories and sharp lines, species, origins, beginnings, and ends. But evolution doesn't work that way. It moves slowly, unevenly, branching and recombining like a tangled vine. And so our search for the last common ancestor may never lead us to a single skull or skeleton. Instead, it may require us to rethink how we define human identity itself. Despite the brutal conditions of the past, the ancient hominins who survived were not primitive brutes. In the Middle East, we have evidence of controlled fire use dating back 780,000 years. In East Asia, Peking man made tools, scraped hides, and perhaps even drilled objects for reasons we still don't understand. Homo erectus in Southeast Asia engraved zigzag patterns into shells and may have used barbed stingray stingers as spears. These actions suggest more than just survival. They suggest curiosity, creativity, and maybe even symbolic thought. If they could make boats, cross into isolated islands, decorate objects, they were more than mere animals. They were innovators, explorers, and possibly storytellers. And the story didn't end with them. Today, fragments of their DNA live on in us. Neanderthal genes shape our immune systems, our skin, even how we respond to sunlight. Denisovan DNA helps some people survive in high altitudes and resist certain diseases. And the unknown ghost lineage of Africa still whispers across the genome of millions. We are not just Homo sapiens, we are mosaics, carrying the legacy of forgotten peoples whose names we may never know. The split that began more than 600,000 years ago was not a single event. It was a drawn-out process of fragmentation and survival. Most of the branches that split off from the human tree ended in extinction. Ours did not. But we are shaped by those other branches in ways we are only now beginning to understand. So where did we come from? The truth is, we still don't know. The story of human origins is more tangled, more beautiful, and more mysterious than we ever imagined. Every new discovery raises more questions. Every bone, every gene, every tool tells us that we are part of a much larger, older, and more diverse family. And this family, scattered across continents and centuries, did not simply vanish. It lives on, in us. If you're fascinated by stories like these, of ancient secrets, forgotten ancestors, and the deep history written in our bones, don't forget to subscribe to Prehistoric Medievals. Join us as we continue to uncover the untold stories of our distant past.